Alright, good afternoon, everybody. So for today, we'll be taking sequence and series. This is part one of the course. So, what's a sequence? We said that a sequence is an ordered list of items in which each surrounding term can be obtained from a simple rule or logic. So these are examples of sequence, and these are finite sequence. We'll get there. So finite means that they have an end. They have a beginning, which is minus 20. That's an end of 10. Look at this one. That's the beginning, the first term as 2 and 8 as the last term. We also have minus 16 minus 1 over 4. Alright, so let's get started. So we've already said that a sequence is an ordered list. It's ordered by some kind of logic. Now if you take a look at this now, the first term here is what? Minus 20. The next term is minus 15. So what's the trend? It's as if you're adding plus 5. So it's just like, okay, I'm adding plus 5 to this. So minus 20 plus 5 is minus 15. Minus 15 plus 5 is minus 10. Minus 10 plus 5 will give me minus 5. And minus 5 plus 5 will give me what? 0. 0 plus 5 will give me 5. 5 plus 5 will give me 10. So that's how it is. Now if you look at this now, this is 2, 4, 6, 8. So what's the trend? It's as if you are adding what? Plus 2. We're adding plus 2. We're adding plus 2. So for the other one now, it's as if you are multiplying by a fraction. Say you are multiplying by minus 1 over 4. It makes sense. Minus 16 times minus 1 over 4. Minus cancel. Minus times minus is plus. So 4 is 16, 4. So we are going to get the next term 4. Multiply 4 by minus 1 over 4. You have minus 1. So that means the trend here is you are multiplying by minus 1 over 4. We are multiplying these two by minus 1 over 4. So this is what we refer to as sequence. Sequence is an ordered list that progresses by a certain logic. So you have to figure out that. Then when we now come to, okay, what's a series? We say that a series is a summation of all the terms of a given sequence. So when you sum all these things together, that's when you're having a series. How together? So a series is a summation of all the terms of a given sequence. Now this last one I put here is what we call Fibonacci sequence. Fibonacci sequence in the sense that, okay, you know, if you count numbers, okay, 1, 2, 3, 4, 5 is an ordered counting system. For example, now look at this now. There's no, you see that the logic is quite simple now. 1 to 2, what's the difference? Plus 1. 2 to 4, plus 2. 4 to 7, plus 3. 7 to 4, plus 4. Now if you want to guess the next term, now what will be the next term? Yes, the next term will be 11 plus 5. That will give us what? 16. So the next term is going to be what? 16. And the difference here will be plus 5. If you want to get the next term, it will be plus 6. 16 plus 6. That will be 22. So the next term is going to be 22. So that's 22. Yes. So this is a Fibonacci sequence. In such that it is a counting system. 1, 2, 3. The difference is like you're adding. It's progressive. You're adding. It's like the order or what you're adding is consecutive numbers. You can see 1, 2, 3, 4, 5, 6. So this is regarded as a Fibonacci sequence. So sequence is just like, okay, you looking at the pattern, trying to predict the next number. For example, now, if you want to predict the next time here will be what? 15. The next time here will be what? 20. So these are what? Sequence. Now let's continue. So we refer to something as AP and GP. AP in the sense that it's arithmetic progression. Arithmetic means that you are adding numbers, you're adding it, and the sequence is progressing. So arithmetic progression, we have geometric progression. So for today, I think we'll just be making use of arithmetic progression. So for example, now this sequence you're seeing here is finite. Finite is that it has a beginning, the first term has 2, and the end has what? 20. That's the last term. So it's finite, you can count it. But in finite sequences, when you have this dot dot dot, you already know that, okay, it goes till you don't know the particular end of it. So it's regarded as what? Infinite. This is finite and this is what? Infinite. Now for example, now we have something under this AP. Now we'll be treating something as A as first term. Your T1 is also the first term, which is also the same thing as your A. T1 is first term, which is same thing as A. A is the first term. So you have T2, the second term. Your T2 is the second term. And your L is going to be the what? The last term in the sequence. For example, now let's look at this here. A will be 2. It's also same thing as T1, which is the first term. So this will be T1, this will be T2, T3, your 8 is T4, this is T5. So what will be the last term in this sequence? The last term is what? 20. The last term in this sequence is what? 20. First term, second term. And we refer to something as D. D is regarded as a common difference. So your D is common difference. Common difference is that in the sense that your D is T2 minus T1, T3 minus T2. So what you're actually doing is you are subtracting the first term from the second term. You understand? You're subtracting the first term from the second term. So for here now, for example now, the common difference here will be what? 4 minus 2, which is 2. Common difference will be 6 minus 2, which is 2. Or basically, what are you adding? I'm adding 2. I'm adding 2. That's regarded as your what? Common difference. So, okay, if you want to have a trend, that means you have it as your first term as A. The next term will be A plus your common difference. It makes sense. If A is 2, if we add 2 to it, 2 plus 2 will give us 4. 2 plus 2 plus 2 will give us 6. So the term is A plus D, A plus D plus D, A plus D plus D plus D. So you have A plus D, A plus 2D, A plus 3D. So this will be T1, T2, T3, T4. Alright. Now they said that to get the term in a sequence, if you want to get the particular term in a sequence in an arithmetic progression, what do? You use this formula that says that Tn is equals to A plus n minus 1D. That is if you want to get the term in a sequence. You want to get that particular term in a sequence, you use the formula Tn is equals to A plus n minus 1D. For example, now let's make use of that above this sequence in particular. So if they say calculate the fifth term now, that means our answer should be 10, Abi. So how do you calculate the fifth term? Let's make use of this formula that says Tn is A plus n minus 1D. That means T5 will be, what's the first term in that sequence above? 2. Plus, what term are we looking for? The fifth term. That will be 5 minus 1 times, what's the common difference? 2. You can see that we later got what? 10. And if you look at it here now, what's the fifth term? 10. I hope it makes sense. So if they tell you, okay, what is the term in a sequence? You just use Tn is A plus n minus 1D. Are we together? Now, let's just stop at there for now. So just take note of this formula, which is Tn. To get the term in a sequence for an arithmetic progression, your Tn is A plus n minus 1D. Alright, let's continue. Now, okay, what do you mean by sum? If you want to do the sum of AP, so sum of arithmetic progression, for example, say you have 2, 4, 6, 8, 10. Then I tell you that what's the sum of the sequence above. Now imagine if you have 100 terms, you need a formula. You can't be counting now. For example, now what we just do is this. Okay, the formula is xn is n over 2a plus l, where l is last term or Tn. So for example, now the last term here is 10, Abi. So that will be our last term here. So you just take your 2 plus 10. Then what term are you looking for? How many terms are here? 1, 2, 3, 4, 5. So let's just take note of the formula for now, that if you want to calculate the sum of an AP, it will be xn is n over 2a plus l, or xn is equals to n over 2a plus, that l is the same thing as Tn, which is the last term, which is what? A plus n minus 1. So this thing here is like your Tn, or last term. So Sn is n over 2a plus n minus 1d. So by the time you add this a plus a, you have 2a plus n minus 1d. So take note of this formula. If you have your last term, you make use of this. Or if you are confused, just make use of the general formula. So for example, now you have 2, 4, 6, 8, 10. The question now says calculate the sum for the first 5 terms. What are the first 5 terms here? 2, 4, 6, 8, 10. Now let's do something. Let's use the formula. We can say that xn is equals to what? N over 2 into what? 2a plus n minus 1d. So what is our n here? Our n is going to be what? 5, because we are looking for the 5 terms, the sum for the first 5 terms, which will be 5 over 2 into bracket 2. What's the first term there? 2 plus, what's the n? The number of times we are looking for, which is 5 minus 1 times 2. By the time you solve that, you get 30. Now let's check. In actual sense, what are we doing? You have to understand what we are doing. What we're actually doing is that we want to sum it up. So for example, if you had these numbers now, they will give you 30. So that's 2 plus 4. 2 plus 4, that's 6. 6 plus 6, that's 12. 12 plus 8, 20. 20 plus 10 is 30. So you can see that If you want to sum it up, you get 30. If you make use of the formula, you also get what 30. But imagine you have 100 terms. Are you going to now be adding up the 100 terms? No. That's why this formula is what is very important. It's very crucial. So the next thing I want to do is the question now. They said if the fourth term of an AP is 8 and the 10th term of an AP is 20, find A, the first term, B, common difference, C, 15th term, D, sum of the what? 15th term. You are given an arithmetic progression whereby you've been told that your fourth term is 8, your 10th term is 20, and you are now told to find the first term, the common difference, the 15th term, the sum of the 15th term. Now the first question says find the first term. Now let's just, in this kind of situation, you're having two simultaneous equations. It will be leading to an equation. Why? Because you are not given many details, but you have been given two necessary details. So if you've been told earlier that the fourth term is 8, so how do we express fourth term? Fourth term will be a plus n minus 1d. So if we put it in this Tn, that will be T4 is a plus 4 minus 1, 3d. So T4 is a plus 3d, which is equals to 8. T10 will be a plus 9d, which is equals to 20. By the time you solve this, which is a plus 3d is 8, a plus 9d is 20. Take subtraction. A minus a cancels out. 3d minus 9d minus 6d. 8 minus 20 minus 12. By the time you solve, d is equals to minus 12 over minus 6. You have 2. Therefore, our common difference is 2. We have actually solved b, which is our what? Common difference. So now you can now make use of your common difference to get your first term. So substitute into every equation, whether equation 1 or 2. So you can say that let's substitute it into equation 1. So a plus 3d is 8. A plus 3 times 2 is what? 8. So a plus 6 is 8. You get your first term to be what? 2. That means the first term is 2. The common difference is what? 2. Now let's look at C. C says you should calculate the 15th term. So what's the formula for calculating the 15th term? We know that Tn is a plus n minus 1d. That means T15 will be 2. What's our first term rather? First term is 2. That will be 2 plus 15 minus 1 times 2. By the time you solve, you get what? 30. So our 15th term is what? 30. Now the last question says find the sum of the 15th term. So you have to find the sum of the 15th term. So what's the formula for sum of 15th term? That will be xn is equals to what? N over 2, 2a plus n minus 1d. So what term are we looking for? The 15th term. So that's the sum of the 15th term is 15 over 2 into 2 times the first term plus 15 minus 1 times 2. By the time you solve it, you get 240. Now, I told you can as well use the other formula. So I gave you this question so that you can see we can also use this other formula. And what's the other formula? The other formula says that xn is n over 2a plus l. Are we together? Sn is equals to n over 2a plus l. So since you already know the 15th term, you know in the previous question, we got our 15th term already. And since the question is telling us find the sum of the 15th term, you already have the idea of the last term. And the last term is the 15th term. I get the term we calculated earlier is the 15th term. And since the question asks us the sum of the 15th term, we already have an idea of the last term. So why not use the last term straight up? So that's why you now say, okay, Sn is n over 2a plus what? L. So since we know the 15th term, S15 will be 15 over 2 plus the last term, which is 30. You still get 240. You still get what? 240. So this formula holds. So this is part 1 of the course. So we continue our next part very soon. So we'll be treating geometric progression, then sum to infinity in the next video. Thanks for watching.